Now, if you're thinking to yourself, good gracious, that was way too much math, and I'll never learn that process, don't be too discouraged. There's actually a trick for this. Let's look at this limit. This is similar to the problem we worked on just then. I'm taking the limit as x approaches infinity, and by doing so, we'll notice that this 3x squared term is growing very fast. I mean, as x is getting huge, as a huge number, x squared becomes even larger. But the 5 does nothing. Nothing's happening to that 5. So really what's happening is this is growing out of control, whereas this is kind of just not doing anything. It's becoming irrelevant. Similarly, this term on the denominator is growing out of control, whereas this term is becoming irrelevant. So the trick is this. If you're evaluating a limit at infinity, as x is approaching infinity, just look at the largest terms and take the coefficients of those largest terms. So in this case, the largest term is x squared, and the ratio of the coefficients is just 3 over 4. That's the same answer we got before. Here's another example. Let's say we have the limit as x approaches infinity of this right here. X squared is growing large. 5 is not doing anything, so that we can kind of ignore that. And x is not growing nearly as fast as x squared. So this limit actually becomes infinity because the numerator is growing much faster than the denominator. So this is kind of like infinity, or infinity over 1, you could say. Another example, I'll keep doing the color switch. Another example is this right here. The limit as x approaches infinity of this business. And let's look at the terms. We have on the numerator 4x to the 7th, okay, plus 2. In the denominator we have 16x to the 15th. Whoa, well this term is much larger than anything else here. So all of these other things will be irrelevant once this number starts growing very huge. So this is just going to approach 1 over infinity because this term is going to be irrelevant. This term over here is going to be irrelevant. The only term that's going to be relevant as I get close to infinity is this guy right here. And so that's just 1 over infinity, which is, of course, a very tiny number. So tiny that we could say it's 0.